All right, so another problem that has come up for a number of students is the one where it gives you kind of the example. Okay, so here's what's meant by the problem. So you take a cardboard box or piece of cardboard that's 10 by 18. Okay, again, it doesn't matter which dimension is which, and you're going to cut it so that you can fold up the corners or fold up the sides and form a box that has a specific volume. So what we're going to do is if we want this box to be uniform in its depth, we just have to cut out a square that's the same dimensions in each direction. Okay? So these parts that are cut off here in blue, so right here you'll remove those corners, and this is what's going to be left to create your box. Okay, so let's take a look at what kind of that side view of the box looks like. Okay, so you know that the depth of that box is x. Okay, this front part right here maps onto this piece. Okay, and so what we're doing to find this piece is we're taking this entire quantity 18, we're removing an x from each of these ends, so we're going to be left with 18 minus 2x. Okay, we can do the same thing over here to find this length. It's represented by this piece. Okay, again, because we're going to be folding this box at these dashed lines to form the sides. Okay, so when we want to find what this length is, we take the whole length of the original cardboard piece 10 and we remove x units from each of the ends to account for that tab. And so once again, we're starting with x, but we're removing an x and another x, or we're starting with 10 and removing 2 x's from it. Okay, so those are going to be your dimensions for this box. So what you want to do is you want to figure out what would be the maximum volume of the box. Well, the volume is length times width times height. So if the length is, let's call it, it doesn't matter which order, but x, 18 minus 2x, and 10 minus 2x. Those are the dimensions. Okay, so if we go ahead and we plug these into our y editor. Okay, so on my y editor, I'm just going to take x times the quantity 18 minus 2x times the quantity 10 minus 2x. Okay, so I get my function. Okay, and I now want to view the graph because on my graph, you can see it's a cubic function. Okay, so it's going to look something like this. Okay, we want to find this maximum. Okay, we want to find the hilltop on that, the portion of the graph that contains one. So when we go to our graph and view it, I may have to change my viewing window. It looks like I'm good here. Okay, so you see it fits this same pattern. Okay, so here this is going to give me my maximum volume for this box. And so if I use F5, this math tab, designate my maximum, and then just measure my lower bound needs to be somewhere to the left of and below that highest point. So my crosshairs are good here. Oops. Okay, so there's my lower bound. I need to create my upper bound somewhere to the right and below that highest point. And when I do, I get my corresponding values. And so it looks like it's 2.06. So when you look at that, the coordinate of your highest point is 2.06. It asks you to round it to the nearest tenth, I think. So to the nearest tenth, this x value is 2.1. And then when you plug that into each of the expressions, you get the others. So you see right here, if we took our expression 18 minus 2 times 2.1, you get 13.8. So this is 13.8 for its dimension. And then 10 minus 2 times 2.1 gives you 5.8. And so you have your 3 dimensions. Again, the order of it, it should specify how I want you to enter the order.